The session will highlight how architects can contribute to flood mitigation. And then we're also going to look at how architects can collaborate with environmental scientists, urban planners, and disaster management agencies. So these are our neighbors. You can actually see, I want to define the types of flooding that we have. This is defined as flash flooding, one of examples. And flash flooding is defined as a sudden localized flood of short duration caused by extremely heavy rainfall which overwhelms drainage systems. It can cause rapid water level rise in creeks and streams, making the water move very fast. Floods, which is caused by extremely heavy rainfall, which overwhelms drainage systems. We have coastal floods. This happens along the coastal lines due to storm surges and high tides pushing water onto low-lying lands. We have groundwater floods. These occur when the water table rises and water emerges from the ground, often after prolonged periods of rain. During times of rain, some of the water is retained in ponds or soil. Some is absorbed by grass and vegetation, some evaporate, and the rest travels over the land as surface runoff. Floods can occur when ponds, lakes, riverbeds, soil, and vegetation cannot absorb all this. So what are the causes of flooding? We have two types: natural causes and human causes. The natural causes, of course, cannot be controlled. Heavy rainfall, the climate change, due to the depleting ozone layer, resulting in increase in temperature, resulting in glaciers, increased water table and precipitation leading to the overflow of rivers. We also have the topography and soil conditions, the failure or collapse of dams, like what happened in Maiduguri. Then the human causes are building in flood-prone areas or on river floodplains. Then the other is urbanization. Construction of buildings, highways, driveways, parking lots, which increase runoff by reducing the amount of water absorbed by the ground. As cities grow, more and more land is covered in concrete, tarmac, which is impermeable. So water cannot soak into the ground, which means water runs off over the land. So water runs over the land as surface runoff. So if you look at the diagram, I don't know if you can take us to the diagram, where you have natural surface, you have 40% of that rainwater going up as against the 40% transpiration, you now have 30%, 10%. So other factors contributing to this is or decrease the speed of runoff. So I don't know if you have heard of any flood happening in the forest. It's usually where we have the built-up areas. So now the intervention, design intervention with collaboration with environmental scientists. So we have a reconnaissance survey, should have a complete team that should be taken to site to assess it and give and prepare the findings and solutions before allocation of plots, design and construction works commence. This will help us to understand the terrain and provide proper solutions before construction, as most times construction is carried out during the dry season without proper study and no consideration for rainy season. If all this is put into place, flooding can be mitigated and the risk of flooding can be prepared for. Then the conceptual design stage. During the conceptual design stage of architectural design, the land surveyor should be taken into cognizance. That's one. Topography of the land and the natural flow through gravity or surface runoff is identified. But we have the land surveyors who provide crucial elevation and drainage data for floodplain mapping and defining property boundaries for recovery of communities, understand flood risk, manage land use effectively, and create more resilient development in the face of increasing climate change challenges. Area to include the infrastructure layout and how it will be connected to the seawall route if available. They also prepare the environmental impact assessment report here in the real estate. So you know that before you even get any building plan approval, they have to give you this EIA report by the urban planner.